Greetings, Mr. Sutton here, bringing you the Pre-Cal Honors 4-2 Part 2 homework solutions on compound interest. For number 1, we're investing $60,000 at 1.15% compounded continuously for 25 years. How much will that get us? So because it's continuous compounding, we will use the PERT formula, P times e to the RT. Our P, principal, is the 60,000 we're starting with. For the R, that's going to be 0.0115, and 25 will be our T value. So we just have to plug it in the calculator now. So there we are, plugged it in. To get e to an exponent, again, we do second ln. So now that we've got that, pressing enter gives us $79,985.44. For this problem, we have Imani investing $7,905 in an account with 4.93% interest, not too shabby, compounded daily. We want the balance after 8 years. Since we're not compounded continuously, we use PB to the T. And for my B value, I've got 1 plus my interest rate of 0.0493. And we're compounding daily. So how many times a year is that? 365, unless it's a leap year. We'll assume it isn't. And then we raise that to the 365. Let's see what the calculator has to say about all that. There we go. Plugging all that in now, and I'm storing it as B so I don't have to write all this ever again. That comes out to about 1.0505, but I'm not going to round it off when I actually plug it in the calculator. So what am I plugging in? I'm going to have my f of 8 here, equaling my principal of 7,905 times my B value that I just calculated, raised to the power of 8, because it's 8 years we're doing this, and back to the calculator. So I'm going to use B for that big value there, and this is all going to come out to about $11,726.71. For number 3, 3,500's invested at 4.75% compounded continuously for 12 years. How much does that give us? So we'll need the PERT formula because it's continuous compounding. We'll have 3,500 times E. The R is going to be move the decimal back 2 on this, so 0.0475. Time is 12. So we'll plug 12 in for T there, and let's see what that comes out to. So there's what I'm entering in the calculator. And if we do that, we get $6,188.93. For number 4, we're investing $550 at 20% compounded continuously for 30 years. So that'll be our PERT formula for continuous compounding. We've got $550 for P times E to an R value of 0.2 times 30 for T. Calculator time. So entering all that in and pressing enter, ooh, that's a very big number. $221,885.84. So it goes to show you, if you have even a small amount of money at a high interest rate for a while, it can add up. For this problem, I'm investing $1,000 at 7% compounded continuously. How much money is in the bank after 5 years? So since I'm compounding continuously, that's my tip-off that I need to use P times E to the RT power, the PERT formula. I have a principal of 1,000 times E to the interest rate of 0.07 times a time of 5 years. And now this just is a calculator problem. So plugging all that in the calculator with my special E to the exponent button right here, if I do second ln, that gives me $1,419.07. On this problem, we have Adam investing $7,499 in an account with 4.82% interest compounded 6 times a year. We want the balance after 7 years. It's not continuous compounded, so that's PB to the T we're using. For the B value, we have 1 plus my interest rate expressed as a decimal, so 0.0482. We're compounding 6 times a year, so that's the K value I'm putting down there, and raising it to the same K value. Use the calculator now to figure out the B value. So plugging all of this in and storing it as B so I can use it again, I get a B value of 1.0492 if I round it off. I'll round it off here, but I'll use the true value on the calculator. So now that is going to be f of 7. I've got a principal of 7,499 times the B value we just figured out there, raised to the power of 7 for the years. So doing that on the calculator, using B for that stored value, we end up with $10,494.19. For 7, we're investing $4,361 at 5.35%, compounded continuously for 12 years. Let's see what we have for that. So we've got the PERT formula for continuous compounding. We've got a principal of 4,361 times E to our interest rate, which is going to be, if we move the decimal, 0.0535, times the T value of 12 for 12 years. So if I plug all that in my calculator, it should come out to about $8,287.11. On this problem, I want to know how much I'll have if I invest $12,300 at 9.69% interest compounded continuously for 7 years. Since I'm compounding continuously, I need my PERT formula, P times E to the RT. So that's going to be a principal of $12,300 times E to the interest rate, which is 0.0969 times a T value of 7. And now for the calculator. So plugging all that in, we end up with $24,237.46. For number 9, we're investing $675 at 17%, compounded continuously for 21 years. So we'll use the PERT formula for this. That'll be 365 times E. The R value here will be 0.17 if we move that decimal, and then a T value of 21 years. Plug in all that in the calculator here. That's going to come out to $23,973.70. For this problem, we have Troy opening a savings account with $600 as the principal, accounts earning 500% interest compounded continuously, and this is going to be after 6 years that we want to check the balance. So for continuous compounding, we use our PERT formula, P times E to the RT, and then for my principal, I've got 600 times E to the interest rate of 0.05 times a time of 6. On the calculator now, plug in all that in. This is going to come out to $809.92.